All right, welcome back. Sorry. We are on Unit 6, which is plane geometry, and today is day 3. We're going to talk about quadrilaterals. All right, a quadrilateral is a four-sided polygon. Both of these figures are quadrilaterals. 1, 2, 3, 4 sides. 1, 2, 3, 4 sides. If it has 4 sides, it is a quadrilateral. A convex quadrilateral is a convex if the line segment containing any 2 points inside the quadrilateral stays inside the quadrilateral. It doesn't matter what 2 points I pick inside the quadrilateral. If I connect them, I stay inside the quadrilateral. Concave is a quadrilateral if you can find 2 points inside the figure. See how they found this one, and that if you connect them, that connection, this part of the line, is outside of the polygon of the quadrilateral. That makes it concave. Okay. All right. So types of quadrilaterals. Described below are some quadrilaterals with special properties. A parallelogram. So what you need to know about a parallelogram: both pairs of opposite sides are parallel. So this side is parallel to this side, and that's what those arrows mean. See how there's 2 arrows on top and 2 arrows on bottom? That means that those 2 sides are parallel to each other. Opposite, the other 2 sides, this side and this side, see how this one has 1 arrow and this one has 1 arrow? Those sides are parallel to each other. Opposite sides are also congruent, and that's what these little lines mean. 1 little dash here and 1 little dash here means that those lines are of equal length. And same up here on the red, there's 2 lines and 2 lines, which means that those 2 red lines are congruent. Opposite angles are also congruent. So if you look at this angle up here, opposite would be this one. Those are equal angles. And same with over here. See how they've got two arcs and 2 arcs here? That means those 2 angles are equal. So opposite angles are congruent. And consecutive angles are supplementary. Consecutive means next to each other. So if I take this one and this one, they're consecutive. They're next to each other. Those are supplementary. Okay, so those have to add up to 180 degrees. The other thing that you need to know is that the diagonals bisect each other, which means they intersect each other where this half is equal to this half. And see the 3 lines here are equal to this half. The point of intersection is called the midpoint. Okay? A rhombus has all the properties of a parallelogram. So all of these things are true about it. Plus, all 4 sides are congruent, meaning not just opposite sides are equal, but all 4 sides are equal. A rhombus is kind of like a square, but it's kind of been shifted to the side. All 4 sides are congruent, and diagonals are perpendicular to each other. Okay? And they do, again, all of these things are true. So the diagonals bisect each other, so this equals this, and this equals this. Opposite angles are congruent, opposite sides are congruent, opposite sides are parallel. All of those things are true, but in addition to that, all 4 sides are congruent, and the diagonals end up being perpendicular to each other. Okay, a trapezoid has one and only one pair of opposite sides that are parallel. So see how these 2 sides are parallel, but these 2 sides are not. They're going at different angles. Okay, so a trapezoid just has one pair of parallel sides, and they're not equivalent. They're not congruent. A rectangle is 4 sides. Obviously, it's a quadrilateral. It has all of the properties of a parallelogram. So again, all of these things are true. But all 4 angles are congruent and measure exactly 90 degrees. And again, your diagonals are congruent. So this length is equal to this length. Okay? A square has all the properties of a parallelogram, so all of this is true. It has all the properties of a rhombus, so these are true. And it has all the properties of a rectangle, so these facts are true. Okay? So, let's see what else we got. Relationships among quadrilaterals. Shown below is a partial list of statements describing the relationships among quadrilaterals. It says every rectangle is a parallelogram. That's true, because remember it says a rectangle has all the properties of a parallelogram. But not all parallelograms are rectangles, because again, rectangles have to have 90-degree angles and parallelograms don't. Some do, if you made it. Okay, that is a parallelogram, but it's not. This is a parallelogram, but not a rectangle. This is a rectangle that's also a parallelogram. Okay, every rhombus is a parallelogram, and again, it told us that a rhombus has all the properties of a parallelogram, but not all parallelograms are rhombuses, obviously, because rhombuses have to have 4 equal sides, and parallelograms don't. Every square is a rectangle and a rhombus, just like we said before. A square has all the properties of a parallelogram, a rhombus, and a rectangle. So you can call a square a parallelogram, you can call a square a rhombus, and you can call a square a rectangle. But you can't necessarily call a rectangle a square, or a rhombus a square, or a parallelogram a square. Okay, they're not all of them. All right, and not all rectangles are rhombuses and squares. Oh, not all rectangles and rhombuses are squares, obviously. Okay, so try this one. Hit pause. Come back when you're ready. And hopefully you got D. They want to know the statement that is not true. A square is a rectangle. Well, again, by that list, yes, because a square is has all the properties of a parallelogram, a rhombus, and a rectangle. So that makes these true. A rectangle is a parallelogram, which is true because that definition said that a rectangle has all of the characteristics of a parallelogram. Opposite sides, I'm going to skip down to E. Opposite sides of a parallelogram are congruent. That is true. It says in my little definition that opposite sides are parallel and opposite sides are congruent. This D says adjacent sides of a rhombus are perpendicular. Well, if it's a rhombus, okay, it has all the properties of a parallelogram and all 4 sides are congruent, but it doesn't, adjacent sides of a rhombus are perpendicular. If that was true, then you would have a rectangle. Okay. Alright, so a little bit of practice. It says a line segment is drawn connecting any 2 points in a quadrilateral. What determines whether the figure is concave or convex? It is concave when you can connect 2 points inside and it stays inside. It is concave when you connect 2 points inside and a section or part of that line is outside. Okay, 2, in a quadrilateral, 2 sides are parallel but are not congruent. What type of quadrilateral must this be? Okay, it just says that 2 sides are parallel but are not congruent. Well, that makes me think of a trapezoid, because it has 1 pair of parallel sides, but they are not congruent because these 2 sides do this. So it would be a trapezoid. 3, for which types of special quadrilaterals can the sum of 2 opposite angles be less than 180 degrees? Well, if you do a parallelogram that isn't a rectangle, it can't be a rectangle. That is not a rectangle. Sorry about my handwriting. My hand's asleep. A trapezoid would be true. And a rhombus would be true. Okay, because like on a trapezoid, if you do opposite angles, this one is acute, this one is obtuse. So how would that work? Can the sum of 2 opposite angles be less than 180? Well, it has to be, because yeah, in a parallelogram, you're doing this sideways, so whatever this one is not equal. Well, yeah, in a parallelogram, opposite angles are equal, aren't they? Opposite angles are congruent. Same with a rhombus. Same with, oh, it doesn't say about a trapezoid. Alright, but those are the ones that the sum of two opposite angles can be less than 180 degrees. Your 90 degree ones, your rectangle, those are 90 degrees, so opposite angles are going to be exactly 180. Same with a square. Okay, opposite angles will be 180. These squishy ones are the ones that their sum will be less than 180. Okay, 4 says, what quadrilateral has diagonals that are perpendicular and congruent? Well, the only one that said that was the square. Those diagonals do come out perpendicular. Okay, part of the characteristics of a square is that it has all the properties of a parallelogram, a rhombus, and a rectangle. Okay, which means that these are not only 90 degrees, but they are also congruent. Okay, and 5, in parallelogram ABCD, the measure of angle B is 90. What type of parallelogram is this? If you have 90 degree angles, you have a rectangle. Alright, 6, what is the name for a parallelogram that has perpendicular diagonals? Well, that would be a rhombus. And actually, a square. A rhombus and a square would. Okay, 7, what is the name for a parallelogram with congruent diagonals? Well, that would be a rectangle and a square. 8, what properties does a rhombus share with a square? Well, all sides are equal. Your diagonals are perpendicular, and opposite sides are parallel. Number 9, what quadrilateral with a pair of parallel sides is not also a parallelogram? It just says with a pair of parallel sides. That's not a parallelogram. Well, again, that would be, I have one pair of parallel sides, that would be a trapezoid. 10, what is the name for the quadrilateral with bisecting diagonals? Well, that would be a parallelogram. Which then, since a rectangle, a rhombus, and a square all share those properties with a parallelogram, that means that their diagonals also bisect each other. So a parallelogram, a rectangle, a square, and a rhombus, technically. Alright, you try this, hit pause, come back when you're ready. And hopefully you got deep. It says an artist wants to draw one geometric shape that has the qualities of two geometric figures. Which of the following shapes could he draw? A rectangle that is concave. Well, that's not two geometric figures, that's just one. A square that is a trapezoid. Well, that's not even possible. A square can't be a trapezoid. A trapezoid that is a parallelogram. Again, that's not possible either. You can't make a trapezoid a parallelogram because a trapezoid has only one pair of parallel sides, and a parallelogram has both opposite sides are parallel. A square that is a parallelogram, that is true, because a square has all the characteristics of a parallelogram. And a parallelogram that is a plane is three non-collinear points that make up a plane, and that's not what we're talking about here. Okay, try this one, hit pause, come back when you're ready. And hopefully you got H. It says, which of the following is a property of a rectangle? Well, all four sides are congruent. That would be a square or a rhombus. Consecutive angles are complementary. Rectangle has consecutive angles that are supplementary because they're 90 and 90 would make 180. Diagonals are congruent. That is true. Diagonals are perpendicular. Not in every rectangle. In squares, yes, but not in every rectangle. And it is a concave quadrilateral. Concave. Concave. No. Concave would be where you connect. If it's a rectangle, any 2 points inside would be connected inside. That's convex. Okay, so that's not true. Alright, hit pause. Come back when you're ready. And hopefully you got a square. What is the best name for a parallelogram that has 4 congruent angles and perpendicular diagonals? Well, that's got to be a square if you look at your definitions. The quadrilateral just has to have 4 sides. It doesn't necessarily mean that they're congruent or that their diagonals are perpendicular. The parallelogram does not have to have, they won't have 4 congruent angles. A rectangle will have congruent angles, but it doesn't its diagonals aren't necessarily perpendicular. A rhombus will have 4 congruent sides and perpendicular diagonals, but the angles aren't all equal. So the only one that fits everything is the square. Okay, try this one. Hit pause. Come back when you're ready. And hopefully you got supplementary. It says consecutive angles in a rhombus must be supplementary. Well, if you are a rhombus and all 4 sides are equal, and we're talking consecutive angles, well, this one is acute, this one is obtuse, all right, and they've got to come out to be supplementary. It's part of the definition. Okay, try this one. Hit pause. Come back when you're ready. The perimeter of a figure is 4 times the length of one side. This figure could be, well, if I look at a square, okay, and I say that this is 4, then this is 4, and this is 4, and this is 4. So the length of one side is 4, and my perimeter would be 16, which is 4 times 4, so yes, a square works. A rhombus has 4 equal sides, so again, if this is 4, then this is 4, and this is 4, and this is 4, and the perimeter would be 16. So again, the perimeter would be 4 times the length of the side. And I kind of struggled with how they got all the above until I thought about this trapezoid. Alright, if I made this side 4, okay, there's the length of one side. It didn't say that sides were equal, it just said one side is 4. Well, I was trying to figure out, could I come up with a perimeter of 16 if I made this side 4, which I could. If I made this 3, and this 3, and this 6, that gives me a perimeter of 16. And one side is equal to 4, which the perimeter is 4 times that, so yeah, a trapezoid also works. Alright, and we are done with quadrilaterals, so I will see you next time.